Okay guys, so in chapter 7 when we're working with polynomials, you're going to see that factoring becomes a really important skill. So what I'm going to do is go over all of the different ways that you can approach factoring and sort of the order in which you should try to see if things factor. So option number 1, this is what you should always look for first, is there a GCF among your terms. So we have a term of 8x and we have a term of 10, and your greatest common factor would be a 2. So in terms of how this factors, we have a 2 times a 4x plus 5. And when you're done factoring, you should always, or you can always check yourself by just real quick thinking, okay, do I get what I started with if I redistribute the 2? So 2 times 4x is 8x, and 2 times 5 is 10, so I get what I started with. So pause the video and try the next one on your own. Alright, so let's see what you did. Hopefully you realized that your GCF in this case would be a 4n. And if we take 4n away from 12n cubed, we have a 3n squared. If we take it away from 8n, we have a minus 2. Okay, so that's the easiest way to factor, and it should actually always be your first method that you try. Now, when you look at some of the problems in option 2 here, you're going to notice they do not have a GCF. So I always ask myself that question, do we have a GCF? In this case, we do not. What's happening in all three of these examples is that they are quadratic, so you see an x squared. Trinomial, meaning you have 3 terms, so quadratic that has 3 terms, where a is equal to 1. When I say a is equal to 1, I mean the number in front of x squared, or in this case b squared down there, is 1. And those aren't too bad. I usually think, okay, we just sort of have to reverse FOIL. So I like to set up my parentheses. I know the first spot of each has to be an x and an x. That gets me the x squared. And then I have to consider all the numbers that multiply to 16. So 1 and 16, 2 and 8, 4 and 4. And then from those, I would pick the numbers that add to 10. By the way, these both have to be plus signs. And 1 and 16 doesn't add to 10, but 2 and 8 do. Alright, so again, pause that video, try the next 2 on your own, and then when you're ready, play it and see how you did. So on the next one here, again, I know quadratic trinomial, no GCF to factor out. I'm going to set up my parentheses, and I know I have to have an x and an x to get the x squared. And this is interesting. I got to multiply to a positive but add to a negative. That actually says that both of those will be minus. Multiplying to 6, so 1 and 6, 2 and 3. I'm going to go with the 2 and 3. They both have to be negative, and those add to a negative 5x. On the next one, again, no GCF to factor out. So to get b squared, I know I have to have a b and a b. Now this is a slightly different situation. We're multiplying to a negative and we're also adding to a negative. And that tells me that I'm going to have a plus and a minus. And if I'm adding to the negative, the bigger number has to go with the negative. So we'll put a 3 here and a 1 here, and we're good. So let's say you're looking at a quadratic trinomial, but the number in front of x squared is not equal to 1. So you can see on each of these examples, the number in front of x squared is not equal to 1. Still look for a GCF. You're going to see that in some of these cases, there is not one. These get a little bit harder in that you may not get the right answer right away. It might take a couple tries. So again, reverse foiling here. I've got to think of things that multiply to 5x squared. Luckily on that one there's not a lot of options. It's x and 5x. Now we have to multiply to a negative, which means one of these will be plus and one will be minus, and I don't actually know which one is which, so I'll just have to do a little guess and check. It may end up being that I switch those signs to get the correct factorization, but we'll have to see. I got to multiply to 14, so that could be 1 and 14 or 2 and 7. I don't actually know which ones. I usually start with the ones closest together, so 2 and 7. So let's just put a 2 here and a 7 here and see what happens. I definitely have the x times 5x is 5x squared. And 2 times negative 7 is definitely negative 14. What we have to check are the inside parts. So this gets me a 10x, and this gets me a negative 7x, and that does not add to negative 33. So that doesn't work. So what this means is we have to try again, and that's okay. X and 5x. And I see that if I put a 7 here, and if I make that a negative 7, I'm going to get a negative 35x. If I put the positive 2 here, that will get me the negative 33x in the middle. So this is the correct factorization. All right, go ahead, pause the video, try the next two on your own, and then play the video when you're ready to see how you did. So on the next one here, 4x squared makes it a little trickier because we don't know whether that'll be an x and a 4x or a 2x and a 2x. Again, I like to start with the ones closest together. I see that we're multiplying to a negative, so one of these will be plus, the other will be minus. If I do, let's say maybe a 5 here and a 3 here, well, that gets me 10x minus 6x. That's not 17x. So this did not work. Now, even if I switch places, because it's a 2x and a 2x, it really won't change anything. So now I got to try x and 4x. And I see that if I put the 5 here, it's going to multiply with the 4x to get me a 20x. Putting the minus 3 right here then subtracts 3x, and I get the 17x in the middle. So this works. On the next one, there's no GCF. So 8x, we're either going to do x and 8x or 2x and 4x. I'm going to start with 2x and 4x and see how it goes. To multiply to 9, but to add to a negative means these are both minus. And let's start with 3 and 3. So that would get me a negative 12x. Minus 6x is negative 18x. I got that one on the first try. So that's all great if we're working with quadratics, but not every polynomial is a quadratic. And so your next option is, well, what if we don't have a quadratic? Then you should probably see if you can factor by grouping. So to group, I will note, you must have an even number of terms. It doesn't work if you have an odd number of terms, and you'll see why in a moment. So with factoring by grouping, what's going to happen is we're going to put parentheses around the first two terms and parentheses around the second. And we're going to take a GCF out of each individual group. So of this first group, we can take an x squared out and we'd be left with x plus 4. In the second group, I can take a 2 out and I'm left with x plus 4. So this x plus 4 now becomes your GCF. So factor out your GCF. So you're going to take x plus 4 away. That's going to be one of your factors. And your other factor, you would have an x squared plus 2. Now I always like to check, can any of these factor further? In this case they cannot, so we're done. Again, pause the video, try the next two on your own, play it when you're ready. Alright, so on this next one, we group the first two terms together, we take out the GCF, and we hope that we end up with the same factor. This is our goal each time. We want to get that same thing in parentheses. That's our GCF for the entire problem now, is an x minus 1. And we're left with x squared plus 2 again. And neither of those factor further. On to the next one. Group the first two terms together. And then I actually recommend that you keep that negative with the 5x in the parentheses. Take out your GCF, which is a negative 5 in the other situation, in the other group. X plus 6 is now our GCF for the entire expression. So we factor the GCF away. That's one factor. The other factor is x squared minus 5. Okay, but what if you go through all of those options and you don't have a GCF, it's not a quadratic, and you can't factor by grouping? Well, your next option is to consider if you have a sum or difference of cubes. Now, the good news is if this is the case, you get to use a formula. The bad news is the formula is a bit complicated. So by sum of cubes, they mean, are you adding two things that are cubed? By difference, they mean, are you subtracting two things that are cubed? So you have to sort of see which one your particular situation fits. So on this first one, I see an x cubed minus 27. The first thing you want to recognize is that 27 is really 3 cubed. So in terms of our formula, the a is an x and the b is a 3, and I'm going to use the bottom one because we have a difference. And so what that says is my first factor is a minus b, so x minus 3, times a squared, which would be x squared, plus a times b, which would be 3x, plus b squared, which would be 9. And there you go. It probably doesn't look like it, but if you distributed those terms back together, you would get what you started with. Now the bottom one is a little bit harder. You'd want to rewrite that first term as a 4x all cubed plus a 5 cubed, so that you can see a is 4x and b is 5. And we have addition, so I'm going to use my sum of cubes formula. And first factor is a plus b, so 4x plus 5, times a squared. If I square the 4 and the x, I get a 16x squared, minus a times b, so minus 20x, plus b squared, so that's plus 25. And there you go. Now, a little trick for remembering the formula. If you're working with a sum of cubes, your first factor is a plus b. So if you start with something with a plus sign, your first factor will have a plus sign. With the difference of cubes, you're starting with something that was being subtracted. Your first factor will also have that subtraction. And then from there, you can see the formula is almost the same, except if you started with a plus sign in your first factor, you'll have a minus ab. And if you start with a minus in your first factor, you will have a plus ab. That's how I always remember it. Let's say, though, you're going through all of those options, and you're looking for a GCF and you don't have one, and it's not quadratic, and you can't factor by grouping, and it's not a sum or difference of cubes. It may mean that you have something that fits this form, a quartic trinomial, where you have an ax to the fourth plus a bx squared plus c. Now, there's actually multiple ways to approach these problems. To start, we're going to sort of treat it a little bit like a quadratic in that we're just going to use our reverse foiling method. If you're going from an exponent of 4 to an exponent of 2 and then down to a constant, you may be able to figure out the factors that you multiplied together. So instead of an x and an x, we would start with an x squared and an x squared. We got to multiply to a positive but add to a negative, so minus and minus. And 3 and 1, that's our only option. That will add to a negative 4x squared in the middle. Now, sometimes after you do that, you're done. In this case, looking at this x squared minus 1, that's quadratic. That's actually the difference of two squares. It factors further into x plus 1 and x minus 1, and that's something you may remember from Algebra 2. On the next one, again, we go from 4, 2 to a number. So we're going to try to reverse FOIL and x squared and x squared to get the x to the 4th, a minus and a minus to get 36 and add to negative 13. Let's do a 9 and 4. Now both of these are differences of two perfect squares, so they factor further. So we actually have 4 factors. So I forgot to circle this one. Alright, so go ahead, pause that video. When you're ready, play it to see how you did on the next 3. On this next one, hopefully you caught that there was a GCF of x before you really started too much here. Then to factor what's left, we have an x squared and an x squared. We gotta do a minus 8 and a minus 1 and multiply to 8 but add to negative 9, and then this actually goes further into x plus 1 and x minus 1. Next one's not as bad. Start with the x squared and the x squared. Do a minus 7 and a minus 7, and that one cannot go any further. The bottom one, you may have realized, is kind of written out of order. So I would recommend rewriting it in standard form first and then trying to factor it. So x squared and x squared. Going to have a plus and a minus. We got to go to 12. So we'll do, oh wait, no, we don't want to, sorry, make both of these minus. Both of these should be a minus. Sorry about that. Got to multiply to a positive, add to a negative. There we go. So we want a minus 3 and a minus 4. X squared minus 3 is done, but x squared minus 4 factors into x plus 2. And x minus 2. Alright. And that is factoring in a nutshell for Chapter 7.